taking the derivative of these two equations using implicit differentiation. Let's go. So the first one, we have a square root of 2x plus y to the fifth equals to 3x. And then first step is I'm going to differentiate both sides with respect to x. So this is 2x plus y to the fifth, and then raised to the 1/2, and then dx of 3x. And then on the left hand side, do you see that we have a 2x plus y to the fifth inside a square root? So this is a composition function. Therefore, we have to do a chain rule. So first of all, we will carry down the 1/2, and then 2x plus y to the fifth raised to the negative 1/2, right? 1/2 minus 1 is negative 1/2. And then we have to take the derivative of the function inside the parenthesis. So what is the derivative of 2x? The derivative of 2x is equals to 2. And then what about the derivative of y to the fifth? So you do the power rule anyway. So you bring the phi down, and then y to the fourth. And then what's missing? You have to write down a dy dx. All right? And then this is a chain rule. So this part is a chain rule. And then the derivative of 3x is equals to 3. Now, what do you have to say to yourself every time you do implicit differentiation? So here is what you have to say. So first of all, you treat y as an x, and then you take the derivative. And then at the end, you write down dy dx. Remember this? We are taking the derivative of y to the fifth with respect to x. So let me repeat this one more time. We are taking the derivative of y to the fifth with respect to x, but we have a y. So this is implicit differentiation. You apply the power rule, bring the phi down, take the phi minus 1. That's how we got the phi y to the fourth. And then since this is with respect to x, you have to write a dy dx at the end. It is just that simple. Apply the power rule and then write dy dx at the end. What about 2x? For 2x, so this is already with respect to x, so there is no need to write dy dx at the end. And then the next step is you have to do a distribution. So you have to distribute this term to the 2. So 1/2 times 2, so that is the fraction, and the 2 got cancelled. So we have 2x plus y to the fifth raised to negative 1/2. And then you take that times phi. Oh, actually, let me take this back. You don't need this anymore because this is one product multiply another product, right? So what? Let me say this one more time. This has no dy dx attached to it. So I can divide both sides by this. All right? And then the 2 plus phi y to the fourth, dy dx stays on the left. And then we have 3 divided by that. So 3 divided by 1/2. And then 2x plus y to the fifth. And then negative 1/2. So this one, we can flip the 2 to the top, and then the negative 1/2, we can bring that to the top and then get rid of the negative exponent. So now we have 2 plus phi y to the fourth, and then a dy dx that is equals to 2 times 3 is equals to 6. So we have 6 square root 2x plus y to the fifth. And then the next step is we can subtract 2 on both sides. So we have phi y to the fourth dy dx. So we have 6 square root minus 2 on both sides, and then we divide both sides by phi y to the fourth. So at the end of the day, your dy dx is equals to everything on the left hand side divided by phi y to the fourth. So we have 6 square root 2x plus y to the fifth minus 2 divided by phi y to the fourth power. So you can take this as your final answer. So that's the first one. And then moving on to the next one. So the next one, we have 1 divided by x to the fourth plus 3 divided by y squared equals to 5. So let's bring the denominator up. So we have x to the negative 4. Save some space right there. So x to the negative 4 plus 3 y to the negative 2 equals to 5, and then we differentiate both sides with respect to x. So d dx and then d dx. All right, the derivative of x to the negative 4, bring the negative 4 down. Negative 4 minus 1 is negative 5. We don't need a dy dx because this is already with respect to x. However, for the next term when you do that with respect to x, you do have to add a dy dx. So you bring the negative 2 down, so you have a minus 6. Negative 2 minus 1 is negative 3. So since this is a y, we have to do this with respect to x, then we need to attach a dy dx to it. The derivative of 5 is equals to 0. And then you add the negative 4 to both sides. So we have negative 6y to the negative 3 dy dx. So we have past the 4, right? And then x to the negative 5. And then we divide the negative 6 and the y to the negative 3 on both sides. So we have a dy dx equals to 4x to the negative 5. And then divided by negative 6 y to the negative 3. All right, so the 4 and the 6, so dy dx. So this one, the 4 and the 6, we have a negative, right? 2 to the third, right? And then the x to the negative 5, that is 1 over x to the fifth. The y to the negative 3, so that is 1 divided by 1 over y to the third, which is you flip the y to the third on top. So let's erase that. So you are flipping the y to the third on top. And then now you put everything together. So you have a dy dx that is equals to negative 2y to the third divided by 3x to the fifth. And then this is your final answer. Alright, this is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you're on your way out or new to the channel. I will catch you all in the next lesson. Signing out.